Alright, welcome to the learning target number 3 and 4 video. Okay, in these two targets, you're going to be modeling. So it's going to be very similar. Well, it's going to be bar modeling, but I hope we're also going to teach you some different methods. So I know some of you get scared when you hear the word bar modeling, but this actually makes sense. Anyway, go ahead and flip in your notes to page. I thought there was a page number. I think it's page 8 for you. No, it's page 2. No, it's page 2. Okay. So here we go. Here's kind of how you do these. Okay. So draw models to solve problems involving ratios. So vegan prepares a fruit punch using apple juice and orange juice. So that's the two ingredients, and there's the ratio that person is going to use. It's going to be 4 parts apple and 3 parts orange. Okay, that's the beginning ratio. So whenever you get that fake ratio, or that fratio as I call it, that's going to be what you're going to model. So as you can see, your copy's hopefully better than mine, but I'll kind of draw a line. Basically, they got this big bar here, and they have it cut into 4 pieces, or they got 4 squares drawn. Now what I'll do, usually how I'll model these a little bit differently, is I like to kind of, rather than draw 1 square and then cut it, I like to draw it like this. You should be doing this too. Into 4 pieces there. So I'm cutting it into four pieces, and then I'm going to show it as 1, 2, 3. So that's all I did, and then of course label it, showing which one's the apple, which one's the orange. But it's the same thing. They just connected their squares, whereas I didn't. So I'll put these back on here so you can actually see them on mine. Okay. Now, here's where you use the model to find the answer. So if the total volume, okay, of the fruit punch is 630 milliliters. So what we're saying that both of these bars, both of them are representing 630. That's what we're doing. We need to find the amount, or find the volume of apple juice Megan used. I guess that was Megan. I don't know why I said vegan. Okay. Okay, so we know that all of these squares right here represent 630. So it kind of goes through it down here, but what we're going to do is we know that each one of these squares is representing the exact same amount of liquid. And that's what we got to find out first. We got to know how much is each one of these, what's the amount of each one. So we have 630 milliliters. That's what the whole thing is. We're going to take it and we're going to divide it by 7. Okay, as they did right here. So it's kind of already done for you here. And that's going to mean 90. So that means that each one of these is 90, 90, 90, 90, 90, 90, and 90. Okay? So from here, all you do at this point is, now if you know that each little square is representing 90, and I could do the same thing over here, I won't, but it could be, then you have to say, okay, what was the volume of apple juice that I used then? Because that was the question. Well, if each little square is representing 90, and we have 4 of them, we do 90 times 4, and we know that the volume of apple juice was 360 milliliters. Okay. Now, if we wanted to figure out how many milliliters of orange juice she used, we would do 90 times 3. Okay. So I think you guys are going to catch on to this pretty quick here. Okay. Here we go. Now, if Megan uses 520, put my lines in here again, just showing 4. 520 milliliters of apple juice, find the volume of orange juice she uses. So just to separate these two for a minute, up here we were given the whole amount, the total of both of them combined. Okay, whereas down here we're given the actual amount of apple juice used. So we know that we used, in this, however much she made, she used 520 milliliters of apple juice. So that means we need to take 520, and we're going to have to divide that by 4, because there are 1, 2, 3, 4 spots. So we do that, and we find out that that's going to be 130 in each one. 130. Okay. And down here I'll do the same, 130. 130, 130. The whole point with a model is to see that each little section is the exact same amount. Well, now it's easy. If you know this is what you're trying to find out, how much orange juice was used, you just do 130 times the 3 squares, and that'll give you the amount of orange juice that was used. So it's pretty easy. It's actually, this is, I'm not bar modeling can be challenging, even for me sometimes. And, these actually make sense to me, to just get your ratio, model your ratio, and then just figure out how much one of those are, and then you can figure out pretty much anything about the problem. Let's go ahead and go to the next page. Okay. A box contains baseball and football cards. The number of baseball cards to the number of football cards is 5 to 1. So what I'm going to do over here is I'm just going to write my ratio. So we all need to put a bracket around that. So it's 5 baseball cards for every 1 football card. I just like to write my ratio over there just so that I have it. Okay. Now remember, when we're modeling, what we're going to do is we are going to model this situation. So just like you see it here. And once again, I'll draw little lines between here, showing how I'm going to show you in different little squares. Now we have 5 to 1. Okay, well, let's see what we know. If the total number of cards is 1,380, okay, that means all total would mean all the football and the baseball cards. We need to figure out how much one of those, how many cards does one little square represent? And we're using this ratio. Everything is based on that. So we're going to do 1,380. And we are going to divide that by 1, 2, 3, 4, 5, 6. Because there are 6 total squares up there. And when we do that, 1 second, 1,380 divided by 6 is going to give us 230. So that means that each one of these little squares is representing 230 cards. Okay? Okay? And 230. Okay? Now we can figure out anything. Find the number of each type of card. Okay. Well, here we go. As far as baseball cards go, we know that we have 230 times 5. And that's going to give us something. And then over how many football cards? Well, we know that we just have 1, so there are 230 football cards. And then 230 times 5 is going to give us 1,150 baseball cards and 230 football cards. Okay? So it's pretty easy, guys. I mean, it's all about just modeling your ratio. That's the first step. So you just model whatever the ratio is. Then determining whether I'm giving you, or the question is giving you, a specific number of cards, like I have this many baseball cards or this many football cards, or is it giving you a total amount of cards? Is it giving us combined football and baseball cards? So this really comes back to part to whole, part to part and part to whole. You'll remember back to review sheet number 13 where I had you turn those part to part ratios, like 12 cats to 15 dogs, and I had you take those and make them to part to whole. And then some of you would have added them and said, okay, that means there are 12 cats for every 27 animals. Okay, that's a part to whole, that's a part to part. Well, this is all this is. I'm giving you a part to part ratio, but you're basically turning that into a part to whole because you're saying, well, that's 6 total pieces. Okay, let's go down here. Now, we're using the same fake ratio here, same exact thing. We know that the ratio of baseball cards to football cards is 5 to 1. Okay, so there we go. The only difference here, again, we are not being given how many total cards I have. We're given the amount of a specific card, and that's the number of baseball cards. So we know that all these represent 950. Well, if all those represent 950, when you model it, all you're saying is, we're going to break this into 5 groups. Okay, so we're going to do 950 divided by 5, and then we're going to get 190 in each one. 190 in each one. Okay? 190. Okay? Now find the number of football cards. Well, that'd be 190. right? Because there's only, if that's how we're doing it, we're breaking it down, that's what we did. We know that each square is representing 190, so there you go. Now, if we also wanted to figure out how many total cards, well, we would do 190 times 6, and that would give us the number of total cards that we have. But it's all based upon this real information. Okay. Now, just to show you guys, the model is great, and I want you guys to use modeling, but I'm also going to, on this one up here, I'm going to go up here, I'm going to show you how a proportion would look. You know that for every 5 baseball cards, there would be 1 football card. You should all be writing this. Okay. Actually, hang on one second. So if you're doing a proportion here, you have to determine, are they giving me a whole amount? They are giving me a whole amount, so that means this is going to be 1,380 total. So that means this is going to have to be total. And then what's it asking for? It's asking for each type. So we'll first do football. Okay? So we know there is 1 football card for every 6 total cards. Okay? And then from here, you just look and say, what am I doing to go from 6 to 1,380? Well, you might have to do 1,380 divided by 6. Work backwards like we did on the review sheet. Okay, when you do that, 1,380 divided by 6, that tells you that you're multiplying by 230. So you got to do the same thing up here, 230. Isn't that what we said the number of football cards should be? So the proportions, I'm going to teach you the proportion also, but I just want you to see the model as well. Okay, down here it would look like this. It's giving you a part. It's giving you the number of baseball cards, the real. Remember, this is my real ratio. This is my fake ratio over here. Okay, and I'm trying to figure out how many total cards. So what's given? I got to turn that 5 to 1 into a part to whole. So it's 5 baseball to 1 football. I know that's going to be 5 to 6. What am I doing to go from 5 to 950? Well, whatever you're multiplying by, it doesn't matter. But you do the same down here, and you end up getting, whoops, you end up getting whatever 190 times 6 is. For the number of football cards. Actually, I've got this backwards. So 950, sorry about this, guys, divided by 5 gives you 190. So you're multiplying by 190. So then you got to do it down here. And that would give you, and that's exactly what we said earlier. We said that that is what you would multiply by. Okay? Go ahead and go to the next page. We're going to skip this page for now. We're going to do this in class. Okay, so just leave it blank. All right, now, learning target 4. You know, realistically, learning target 4 could realistically have been before 3, to be honest. Because what we're really doing is we're finding unit rate with this. Well, that's essentially what we were doing every time back here, weren't we? Weren't we figuring out how much 1 box cost? Or, you know, so that's what it was. Okay, so here we go. Nick fills 24 bottles in 8 minutes. At what rate are the bottles being filled? Well, we want to figure out how much in 1 minute, so we would model how long it would take. So if we know, we would really model that. We would model this. We know that it need to be 8 minutes. So 3, 4, 5, 6, 7, and 8. Okay, all of these are representing 24 bottles. So if we want to know in 1, we would do 24 divided by 8, and that means that there is 3 bottles getting accomplished in every one of these boxes, which is representing 8 minutes. Each one is representing 1 minute, so there you go. And there's your proportion that you guys know. 1 on the bottom, dividing by 8, dividing by 8. Okay? But this is just the model behind it. Okay? Same thing on this one. I know this is really weird. It's almost kind of creepy looking, so I'm just going to get rid of it. Okay? It's better on your copy, I think. Okay, here I know that I can print 405 copies in 9 minutes. Okay? So what I'm going to do is I'm going to model 9, which they've done here. It's hard to see, but on mine. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Then you just got to figure out, okay, if I know that that's not, each one of those is representing 1 minute, I want to know how many copies that would be. So I'm going to do 405 divided by 9. And that's going to give me 45. Whoops. Each one of these is representing 45. So if I want to know in 1 minute, okay, well then that's going to be 1 minute. Okay. Here, you can see the proportion here. You know it takes 9 minutes to do 405 copies. What am I doing to go from 9 to 1? Hopefully you're saying divide by 9. So you do this divided by 9. And then we end up getting 45. Okay? I hope everybody's seeing this. It's pretty easy, and you know you're doing 45 copies per minute. So 45 copies per 1 minute. Okay? Okay? A machine can pack 70 boxes of spaghetti in 5 minutes. Okay? So you model your 5 minutes. Okay? If you know that 5 minutes is representing 70 boxes, we're going to have to do 70 divided by 5. It's going to be 14. So that means that each one of these sections is representing 14 boxes getting completed every minute. Therefore, we know that every 1 minute is going to be 14 boxes. Okay? So if we know now that we can pack 14 boxes in 1 minute, then we could just do 14 times 8 to figure out how many boxes we could do in 8 minutes, or you could model it. 6, 7, 8. Okay, and you know each one of these is representing 1 minute, so 14, 14, 14, 14, 14, 14, 14. And then you just add them all up, or 14 times 8, which is 32, carry 3, 112. So you know it can do 112 in 8 minutes. That's your rate. Okay? Pretty simple, I think you guys are going to think. Okay. Here we go. A unicycle makes 196 revolutions in 7 minutes. At this rate, how many revolutions does it make in 1 minute? Okay. Well, again, let's model our times. Let's model 7 minutes. Okay. I know that I got to do 196, and I need to divide it by 7, because I need to figure out how much each one of these is doing. I mean, that's the whole point of it. It's unit rate. Okay. It's going to be 2 times. Subtract, and I get 5. And then 6. 7 times 8 is 56. And there we go. I know that each one of these is representing 28, so then that would be 28. So it makes 28 revolutions per minute. Okay? And then you want to know how many revolutions it makes in 15 minutes? Well, guess what? If we model 15 minutes, which we would do by drawing 15 squares, again, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? Each one is representing 15, so you're going to do 15, or I'm sorry, you're going to do 28 times 15. And there you go. You end up getting 420. So you know it's 420 revolutions. Okay. All of these are just, all of these could be done with proportions, obviously, also. Okay. Like this one up here, 196 revolutions in 7 minutes. Well, you want to know how many you do in 1 minute. So you divide by 7, divide by 7. It's the same process. Are you guys seeing this? You're taking 196 and you're dividing it by 7 to figure out how much 1 is. It's the same exact thing. We get 28 revolutions. Then you're taking that ratio and you're saying, okay, well then how long in 15 minutes? And then you multiply by 15, multiply by 15. So all of this can be done with proportions. I just want you to see the model, because the model really makes it like it all makes sense of why it's that way. Okay? All right, let's do one more here. Okay, Megan babysits for 5 hours and earns $60. Okay. So we're going to model 5 hours by doing 5 boxes. Okay, you need to do this with me. Okay. Now remember, all 5 of those boxes, oh boy, that's a bad little, whatever that thing's called. It's a bad one, I know that. Okay, all these boxes are representing 60 bucks. That's the whole point of the model. Okay, and what we're going to do is we're going to figure out how much one of those is. So we're going to take 60 and divide it by 5, right? Because there are 5 of them. So I know that's going to represent $12 in each one. Now remember, each block is representing, or each square is representing an hour. This is 1 hour, 1 hour, 1 hour, 1 hour, 1 hour, all adding up to be 5 hours. So how much does she earn in 1 hour? Well, she earns $12. Okay. At this rate, how much will she earn if she babysits for 14 hours? Well, hopefully you know that it's just 12 times 14. But if we were going to model it, we would have to model 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and you know that each one is representing 12. So again, you could add them all up or just do 12 times 14, and you end up getting 12 times 14 is $168. Okay? So pretty easy. The model should just lay it out there for you. Okay? There are going to be parts of the test where you have to model. Okay? So just understand that. Now, remind me in class tomorrow, please, that I want to do these right here in class, and then I also want to finish up this whole page right here. We're going to do those first before we start anything else. So please remind me of that. Okay? So hopefully it makes sense. If you need to, go back and watch anything, but I think you guys are going to think it's pretty easy. See you guys.